All right, so again, good afternoon. Thursday, January 31st, 12 to 1. We're looking at section 4 and 5 today. So let's see, we're going to start today on page 35 in your book. So if you have your book out, follow along, that would be helpful. Let's see. So section 4 here, it says applications of per capita and proportion. So last week we talked about per capita and what it means. And then today we're looking at some applications of that. So it says here, we can also use proportions to consider what-if scenarios. Consider the table to the right, which contains the total number of money spent on K-12 education for the 2014-15 school year. So it has some states there, what the expenditures were in the population. According to the table, Illinois spent $28.54 billion on K-12 education from a population of 12.9 million. With a population of 6.6 million in Indiana, what would be the expected value of K-12 expenditures if the two states were proportional? So if two things are proportional, that means that if you write them as a fraction, they're equivalent. And so we look at this chart, and we see that Indiana we already know the expenditures for Indiana, and that's not what we're looking for. We're looking for the expected expenditures. So we're going to predict the expenditures if it's proportional to Illinois. And so when it says if they're proportional, that means that the other state, we're going to use all of their information. So let's look at the Illinois expenditures, 28.54 billion, and you can write times 10 to the 9th there if you want. And then let's see, their population was 12.9 million, so that's different. That would be times 10 to the 6th. And then we're trying to find out what the expenditures would be for Indiana, and then we're using Indiana's population. So 6.6 million. And if you remember how we solve these, we solve them by cross multiplying and then dividing. So I want you to see that we're going to multiply the 28.54 and the 6.6, and we have billions times millions. Then we're going to divide by this 12.9 million. So we're going to divide by million. So notice how the millions will reduce each other out and we'll be left with billions. So since this is the case, we don't actually have to put the times 10 to the 9th and times 10 to the 6th on these numbers. We'll just know that whatever answer we get will be the number of billions. So to solve this, we would multiply 28.54 times 6.6 and then divide by 12.9, and the answer would be 14.6. And then we would put $1 billion. And then if we wanted to write this in a meaningful sentence, as you've seen questions being asked, we'd say this means that we could expect Indiana to spend $14.6 billion on K-12 education if Indiana chose to adopt Illinois' spending patterns. So we'd say if Indiana was proportional to Illinois. And then it says compare this to the actual expenditures. Well, 14.6 compared to 9.97 is like $4.5 billion more. It's almost 50% more than they're currently spending. All right, so let's look at page 36 and actually do some calculations here. It says here the gross domestic product, the GDP, is the market value of all officially recognized final goods and services produced within a country in a year. The GDP per capita, of course, is the GDP per person. It says it is the market value of all officially recognized goods and services produced within a country per person. GDP per capita is often considered an indicator of a country's standard of living. So the higher the GDP per capita, the higher the standard of living in that country. The table below shows the GDP for several countries in 2012, and they're listed in American dollars. So it wants us to compute the GDP per capita for each country. So I'm going to compute Australia's, and you're going to compute Canada's, and then I'm just going to throw the numbers in for the rest to save us some time. So Australia, notice that this is in billions, and the population is in millions. So when we do this, Australia the GDP per capita would be 1532 times 10 to the 9th divided by 22.0 times 10 to the 6th. So remember, billions is the 9th power, millions is the 6th power. And then we want to put our answers in dollars and cents. And so we want to, not have a power in our answer. We just want to have what is the answer. And when I divided those, I got $69,636 and 36 cents. And so I'd like you to try that and make sure you can get that on your calculator. All right, and then when you've done that, I want you to try finding the GDP per capita for Canada. And when you have it, don't throw it in the chat box yet, but do a hand raise for me so I know that you've got an answer. And I'll give you a minute to do that. Okay, so most of you gave me a hand raise at this point, so we'll move it along. So for Canada, you should have done 1780 times 10 to the 9th divided by 34.9 times 10 to the 6th. And you should have gotten $51,002.87. Oops. All right. And then let me throw the numbers in here for China. Same idea, same calculation. China would be $6,094.07. Madagascar is $455.71 of GDP per capita, and the US $51,732.48. Then you can try those other ones on your own time. Verify you can get those answers. We want to answer these questions just quickly. Which country has the highest GDP? So GDP is right here. Which country has the highest? And it is the US, much higher than the others. Which country has the lowest GDP? And you can feel free to answer either out loud or in the chat box. But that is Madagascar. So which country has the highest GDP per capita? So now that's over here. And it looks like Australia. Yeah. And then the lowest GDP per capita. And that's Madagascar also. So it says China's GDP is more than 4 times the size of Canada's. Why is China's GDP per capita so much less than Canada's? What do you think? Yeah, there are so many more people. Oh my gosh, look at the huge difference in people. So yep, just the sheer population there that China has compared to Canada. So it says if China's GDP were proportional to Australia's, what would China's expected GDP be? And then how does it compare to the actual GDP in China? So let's see. So we're comparing China to Australia, and we are trying to find the expected GDP for China. So that means we're going to use Australia's numbers. So let's see what we have here. The GDP for Australia is 1532 billion, and the population is 22 million. And then for China, we are trying to find what the GDP would be if it were proportional, and we know China's population is 1350 million. And so since we are doing billions times millions and then dividing by the millions again, the millions are going to cancel out and our answer will be in billions. So 1532 times 1350 and then divided by 22. I got about this many billions. 94,009 billion, so somewhere like that. And it wants us to compare this to the actual GDP in China. So the actual GDP in China is 8,000 billion, so 8 trillion. This is actually 94 trillion. So 8 trillion compared to 94 trillion would be like 10, 11, almost 12, between 11 and 12 times as big, right? So if China was proportional to Australia, its GDP would be 11 times what it currently is. So that's the comparison we could make. All right, so let's look at another application. And on page 39, we can find information about the federal budget. Now, the federal budget numbers are a little bit from 2017, so a little bit old. But it says, according to the GPO, in 2017, the U.S. government had an income of $3.32 trillion and expenses of $3.98 trillion. Use this information to think through the problems below. Calculate the difference between income and expenses. So let's see, what's the difference between the income and the expenses, and is it a surplus or is it a deficit? You tell me. All right, so you're saying it's a deficit. No one gave me a number yet, though. So we can do something like 3.98 trillion minus 3.32 trillion, and we get 0.66 trillion, which is 660 billion. So 0.66 trillion or 660 billion dollars. And since the expenses are higher than the income, or if you subtracted them the other way, you would have got a negative answer. It is a deficit, as you noted. All right, I'm just going through your answers here. All right, good job. So the next question says, if the average citizen with a per capita income of $46,550 operated like the U.S. federal government, what would be the expenses for that citizen? So now what we're saying is we're going to take a citizen and we're going to compare that citizen to the government. So we're going to make them proportional to the government. So I'm going to put the government information over here. So what do we have? We have the expenses. I'll just put the expenses on the top and the income on the bottom and make a proportion. So for the government, the expenses were 3.98 trillion. The income was 3.32 trillion. And for the average citizen, their income we have is $46,550, and we're trying to find the expenses. So again, we're going to multiply diagonally and then divide. Notice how we're taking trillions and then dividing by trillions. So whatever answer we get, it'll be the actual dollars and cents. So let's do that. So 3.98 times 46,550 divided by 3.32, and that'll give us dollars and cents. And it looks like you all are getting 55,803 and 92 cents, and that's what I got, $55,000. So $55,803 and 92 cents. And what does that represent? That represents the expenses each person would have if their income was $46,550 and they operated like the government. And that's not good because that's almost $10,000 of debt. So that'd be like I make $46,550 and I spend $55,800, and so each year I would be $10,000 further in debt because I spent more than I took in, and that's not what we want to do. So assuming the U.S. population in 2017 was 326 million people, calculate the per capita deficit. So let's take that deficit. We said it was 660 billion. So times 10 to the 9th. And divide it per capita. So we're going to divide it by the 326 million people times 10 to the 6th. Oh, yeah, the 10 to the 9th came because the 660 billion was the deficit, and billions is 10 to the 9th. And then the 10 to the 6th came because that was representing millions of people. So in this case, we have to use the powers. We can't do just trillions and billions because they don't reduce out. See, in the problem above, we had trillions times dollars, trillions times the regular number, and then we divided by trillions, so we're left with just a regular number. So here, dividing these out, let's see. Instead of putting it to the power, let's actually get the dollars. So 2024 and 54 cents. So what we're finding here is the debt that each person would have to pay in order to remove the deficit from the government for 2017. So, that's like everybody pays their taxes and then they have to pay an additional $2,000 more to get rid of the deficit. And it says compare this with the per capita income. So, okay, so let's take that much and compare it to the income. The income was $46,550. So we're doing a part to whole here because this is the part that a person would have to pay to help reduce the debt. This is the whole because that's their whole income. When we get this value, we can actually change it and use it as a percentage. So when I just divided it, I got 0.043. So that means that 4.3% of the average person's income, my mouse is really not helping me out today, would be needed to pay off the debt. Or we could say would be needed to remove the deficit. All right, so again, sorry about my terrible writing there, but I'm not having fun with my mouse today. All right. So let's see here. Clear out my hand raises for a minute. And I'm just going to check my attendance one more time. All right. So let's see. Moving on to page 41. Are there any questions before we move on to page 41 here? And look at another application. Perfect. All right, so our next application is, I think it's our final application for section 4. Let's see, I just want to make sure through my notes here. Yep, so our final application for section 4, and it's called the Consumer Price Index and Inflation. So inflation is the rise in the general level of prices of goods and services in an economy over time. So, the bigger the increase, the higher the inflation rate from year to year. And so it says the Consumer Price Index, the CPI, is a monthly number that reflects changes in the prices paid by urban consumers for a representative basket of goods and services. So there's this quote, quote, basket of goods and services. So a certain list of products and services that have been tracked since the late 70s and the 1970s. And so what happens is they track these same products over time, and every month they examine how much would these products cost. And it says here the CPI is compiled by the BLS and calculated from the average CPI from 1982 to 1984 of 100. CPI is a weighted average price, which we'll talk about next week. We'll talk about weighted averages to the price, of more than 60,000 goods, services, and housing costs. To the right is a table of the annual CPI values since 1977. The annual value of 172.200 for the year 2000 means that the collection of goods and services that would have cost $100 around 1983 would cost $172.20 in 2000. And then in 2017, they would cost $245.12 compared to the $100 it would have cost back in 1983. So it asks us, what is the trend of the values in the table, and what does this mean for you? Well, the trend is increasing, isn't it? Right? It increases over time. What does that mean for us as consumers? The cost of goods and services is going up. Yeah, it just means that buying the same things we would have bought those years back costs us more money today. So here's what I tell my kids. I tell them, if your income isn't growing as much as inflation is rising, you're actually going behind. And so, here's how that works. Generally speaking, every 10 years, the cost of goods and services doubles. It just is what it is. And so if your income isn't doubling every 10 years, you're kind of going backwards with the amount of buying power that you have. All right, so CPI, let's go ahead and look at this and how we would use it in calculations. So what we're doing in this first problem, it says in 1979, a McDonald's hamburger cost 38 cents. What does that equate to in 2015 dollars? And then what we're doing here is we're saying, if it cost 38 cents in 1979, if the price kept up with inflation, what would it cost today? And then we can make a comparison as to what it would cost if it kept up with inflation versus what it actually costs today. So let's see. Two ways to do this. So the first proportion is set up with dollars over dollars, today's CPI or 2015 CPI versus the old one. So it's like new over old, new over old. The second one is new old price CPI. And this is probably the way I'll write mine, this way here. Okay. So it says here that the hamburger costs 38 cents. So I'm going to do this one here. But we're not going to put CPI 2015 in. We're actually going to put the value in. So we don't know what the cost is. We're trying to find that out. And the CPI from 2015, we have to look it up in our table and then figure out what it is. So 2015, it looks like it's 237.017. So I'm going to put 237.017. And then the old value, 38 cents. And the old CPI in 1979 was 92.6. Or excuse me, 1979, 72.6, yeah. And then what we would do is we would cross multiply and divide. So I wrote this proportion as new and then old, but sometimes I write old and then new, okay? So whatever, it doesn't matter. So when we multiply and divide, we get $1.24, as was noted in the chat box. And so this $1.24, let's see, that means that if the customer paid 38 cents in 1979 and the price kept up with inflation, the hamburger would cost $1.24. So I think that you can probably get a hamburger on the dollar menu, so it only costs $1. So the actual price is lower than the inflation price. I think I haven't been to McDonald's in a long time. So I think that they're like $1 or something like that. So if the actual price, so this is the inflation price, the actual price we'll just say is $1. It might be 89 cents or something, I don't know. That means that that inflation is outpacing the actual cost, and that's a good thing. We like that. Let's look at the next one. According to the National Center for Education Statistics, the starting salary for a college graduate in 1983 was $25,000. What would be a comparable one in the 2013 dollars? So 25,000. The CPI in 1983. It looks like it's 99.6. And then looking at 2013, we're trying to find out what the salary would be, and we need the CPI for 2013. And it looks like 232,957. And so the salary in today's dollars, what would that be? So this would be a starting salary. Looks like you guys are getting 58, 473 and 14 cents. So $58,473 and 14 cents. Yes. Okay, let's look at this last one and then we'll move to section 5 because it's already 20 till. So let's see, suppose a 20-ounce soda costs 25 cents in 1977. What's it comparable to in 2015? So 25 cents, 1977. The CPI was 60.600. We're trying to find the cost of the soda in 2015 dollars. The CPI for 2015. Let's see. Oh, what's that? 237,017 again. And then we're going to cross multiply and divide by 60.6. And it looks like we're getting 98 cents. Awesome. So how does this compare to a soda? And I think I went to a gas station and paid like $1.79 for a 20-ounce soda. So in that case, so this is the inflation price. The actual, I paid $1.79 for a soda the other day. So here, the actual price is way outpacing inflation. So this is a bad deal for us. So what we're saying is if you can get a soda for $1, you're hanging right in there with what the average cost of goods and services has been increasing. Okay. So I guess that means you got to buy them in a 6-pack rather than a single at the gas station to be smart about that. All right. So any questions before we go to section 5? All right, and then I can answer questions after we're done here with these questions. I have planned. So let's look at section 5. So section 5 is called the working with proportions. So really it's, cross multiplying and dividing. It's just how do we set them up? That's what the real question is here. All right, so I'm just going to skip to this. I'm going to show you that the way I set proportions up over the last quarter century of teaching is two ways. Based on the words is over of, percent over 100. That's how we set the proportion up. Or we can set it up as part to whole, because remember earlier we learned that part to whole relationships can be written as a percent. So that would be a percent out of 100. So 100 represents the total, or 100%. So let's look at number 1 here. It says 36 is 40% of what number? So 36 goes in the is spot, 40 goes in the percent spot, and we know the 100 is always under the percent. And it says of, it says, I scratched it out there, I didn't want to do that. It says of what number? So we don't know the of part. And we're just going to solve this just like any other proportion. We multiply the two diagonal ones and divide by the extra number. So 3600 divided by 40. I think that's 90. Yep. And let's set the next one up. 527 is what percentage of 850? So 527 goes in the is spot. It says of 850. So that's the of spot. And it says what percent? We don't know, but we know the 100 goes down there. And so same idea, we're going to multiply these two diagonal ones and divide by the 850. And what do we come up with? 62, it looks like some people got, okay. So this is not just 62, but it's 62% because we're finding a percentage. What percentage? 62%. All right, and number 3, 15% of Americans are left-handed, and there are 314 million Americans. How many are left-handed? So we have the percentage of left-handed ones out of 100. And this 314 million represents the total. So that goes with the 100. And we're trying to find the number of millions of left-handed. So 15 times 314 million divided by 100 is going to leave us with the number of millions. And let's go with 47 point, was there a decimal after that? 47.1, I think I got 47.1 million left-handed people. Or southpaws if you prefer. All right, so just a little bit more to go here. And let's look at number 1 on page 47. So on page 47, we're working with percentages over 100, but still it's the same process. So it says 75 is of what number, and then the percent that we're given is 125, and it still goes over 100. So we set it up the same way. But notice how in the right-hand fraction, the larger number is on top. That means that over here, the larger number is going to be on top, so our answer should be less than 75. So 75 times 100 divided by 125. You guys are on it today. We do get 60, thank you. And number 2, we aren't going to have enough time to do group work today, but let's get through these last 5 problems and we'll answer any questions you have, okay? So it says assume concert ticket prices are 125% of what they used to be. So my percent over 100. And if they used to cost $30, that means that the old price was $30. we want to find the new price. We want to find the 125% value. So old price is on the bottom, new is on the top. 30 times 125 divided by 100. And think about it. If 30 is on the bottom and the 125 is on the top, that means that the top number has to be bigger. That means the ticket price had to go up. So the answer needs to be more than 30, and it is $37.50. Okay, so think about those relationships as you do these and how your answer should be. If the price went up, should the ticket be more? If you got a number that was lower than 30, that should give you a signal that, oh no, something's wrong, and I need to redo it. All right, number 3, the doctor says you need to consume fewer calories. You are currently consuming, or you should be consuming 2,000. You're currently eating 2,600. What percentage is that? So again, the old value is going to go on the bottom, 2,000. The 100%. What are you actually consuming? 2,600. And you know that the percent should be more than 100 because the higher number is on top. 2,600 times 100 divided by 2,000. And I got fast fingers in the chat, so the answer is 130%. I love fast fingers in the chat box. All right, and thanks for participating because I am keeping track. All right, just about wrapping this up here. Actually, what I'm going to do with these last 4 is I'm going to give you the answers, and I'll just set them up and give them to you here. So I'll just do it how I did the last 2. So it says you made a purchase in Maine for $74. You were charged $370 in sales tax. We want to know what percentage that is. So the tax amount is on the top of the $74. Trying to find the tax amount. In number 2, it says 24.7% of the 6 billion people claim German ancestry. How many residents claim German ancestry? So the 6 million people are going down here, 54 to 54. That represents all of the people in Indiana, 100%. The German ancestry ones, are 24.7%. We want to know how many people is that. And let's look at the next one. Your gross pay is $1,800 and $396 was taken out in taxes. So gross pay, that's the amount you get before taxes. So that's the original amount. Oops, 1,800. And then it says 396 was taken out in taxes, and we're trying to find out what percent you had taken out in taxes. And then number 4, the last one here. Jennifer says she has $575 taken out of her gross pay. If 23% of her gross pay is withheld in taxes, what is her gross pay, basically? So the gross pay we don't know this time, but we know the taxes. And we know the taxes are 23%. All right. So let's see, go back through here. I see you guys putting all these answers in the chat box. So I got to back my chat box up a little bit and see where you are. So it looks like number 1, some of you got 5%. That is correct. For number 2, let's see, it looks like you're getting, I don't know if I have anybody with that one. I have answers for number 3, 22%, and that is correct. And number 4, $2,500, right? That's got to be more than the taxes that were taken out. And then let's look at number 2. So number 2, we're multiplying these 2 together and then dividing by 100. And we get that out of the 6 million residents, 1,594,200, maybe 200. I forgot, so I got to put this in my calculator one last time. So 64, 54254 times 24.7 divided by 100 is 201. So since we have that 0.7 as, let's see. Okay, help me say your name. Igina? Igina? I don't know. Help me out. The first or the second? Igina? Or, oh no, I forgot what I said. Igina? Is that right? Igina? Yeah, oh, perfect. Thank you so much. So Igina has in here that it's 0.7, and so just rounding to the nearest person, I put 1594,201 people. And then we don't have time for the Excel today, but I will direct you to it. We have an assignment that is how to make a pie chart, and you can find the directions on how to do that on page 51 and 52.